we have in page 303 of your textbook the areas of the various shapes you should know, and you can see that there's 9 there, but you don't need to know all of them. First one you need to know is the square. That should be work you're already familiar with. The square highlighted there, side squared or length squared, or side times side is another way. Next one is rectangle, length by width. Triangle, half base times perpendicular height, or base times perpendicular height over 2. So there's the base, there's the perpendicular height. It's at 90 degrees to the base, not the slant height. Okay, not that one, not that one, but that one is perpendicular from the base, or 90 degrees from the base. That's the perpendicular height. The next one's there, don't worry about parallelogram or kite, but trapezium is one that we look at. It can be turned into something equivalent to a rectangle. If we look at A and B, the two sides that are parallel, different length usually. If we look at those two and the other two are not parallel in that quadrilateral, A plus B times a half, or A plus B over 2, is the average of A and B. If we average those out, that becomes equal to what we would have in a rectangle, the length. We go half of A plus B to find the average of A and B. It becomes just like the length up there in the rectangle. The height and the width, you can see, are equivalent in the rectangle and trapezium. The next one is a circle, which you may be familiar with already. Area is pi r squared, pi times r squared. The 2 pi r is the circumference, that's not the area, so don't get it mixed up. The last one is a sector. Okay, it's theta over 360 times pi r squared. You can see the pi r squared is the same as with the circle. The angle theta, that's what that symbol is, that loopy one, is the angle inscribed. And if that was 360 degrees, a full circle, you'd have 360 over 360 times pi r squared. 360 over 360 is 1 times pi r squared. If we had 180, it'd be half of pi r squared, and so on. So it's fraction of a circle times pi r squared. Okay, so we've got 1, 2, 3, 4, 5 shapes. Here's some examples. The first one is a rectangle. Make sure you do the 5 things, which is firstly, draw a diagram. There is a diagram already provided here, just to speed things up. We have a rectangle. The formula for the area of a rectangle is length times width, or length times breadth, some people say. The length is 7 meters, the width is 3 meters. So we substitute as the next step, 7 times 3, substitute into the formula. That is 21 meters squared. So we compute, and then lastly the fifth step is to write the answer with the correct units, 21 meters squared. We have a triangle next. Area of a triangle is half of base times height, which is half times b times h. We have basically another version of that formula, which means the same thing. We have base of 11, perpendicular height of 5. We have half times 11 times 5, which is half of 55, which is 27.5 or 27.5 kilometers squared. We have the correct units written. This one is an optional one. It's not one of the ones I've asked you to learn, but it's interesting anyway. It's a parallelogram, and it works out just like the area of a rectangle. So the amount of space you lose on one side is the same as the amount of area you gain on the other. So that'd be just like length times width. 3 times 1.5, which is 4.5 centimeters squared. What if we had possibly the trickiest shape at this stage? What if we had a sector? Sector is part of a circle. So if we had a sector, we draw on the two radii and the arc and an angle. Let's say that we have a sector with an angle of 120 degrees. And we have the radius length of 2 meters. We go through the same steps once we have our first step, the diagram. Second step, formula. Area of a sector is theta over 360 degrees times pi times r squared. Remember, r squared is r times r, not r plus r. It's not the same as 2r. R squared is r times r. 120 over 360, which is a third, times pi times 2 times 2, which is 4. That's 4 on 3 times pi, because the 3 is on the denominator, 4 is on the numerator. You could leave it like that, 4/3 pi, because that's the exact answer. But if you don't like that at this stage, we can use our calculator. 4/3 is 4 divided by 3 equals, and then multiply that by pi, which has its own key, and hit equals, and we have to 2 decimal places. If we take it to 2 decimal places, 4.19 that will round to. So going back to the question, we have approximately equal to, which is shown by wavy equal signs, because it's not exactly that, it's been rounded. So approximately equal to 4.19 meters squared. And now we can turn to some of our own examples in class.